go. So 8.2, confidence intervals with means. Let's read the first question. The mayor is interested in finding a 95% confidence interval for the mean number of pounds of trash per person per week that is generated in the city. The study included 196 residents whose mean number of pounds of trash generated per person per week was 33.7 pounds, and the standard deviation was 8.5 pounds. Round the answer to 3 decimal places where possible. Okay, again, really quick, as we dive into this homework, these questions, we have 1, 2, 3, well, we have just a few questions. This will be very similar to the last section. I want to again remind you about what a confidence interval is. What is a confidence interval? And so to remind you of what it is, I am going to try this situation where I guess a number. So I have a number. I just wrote one down on my paper. I have a number from 1 to 100. I want to do this one more time, not nearly as long as I did last time, just quick. But I want to remind you about what we're doing, what a confidence interval really is. So I have a number from 1 to 100 on my paper here. I've picked a number. I have picked a number from 1 to 100, and it is written down. I've got it written down on my paper. So what I want you guys to do is try to guess, but now I'm going to give you an interval though of guessing, right? We have a certain range of numbers. I'm going to give you a generous range this time. Let's try going with a range of 50 numbers. So you can go from like 1 to 50 or 10 to 60. That's not quite right. I'll say 50 or 51. That would actually be 51, wouldn't it? Anyway, who cares? Just add 50, 20 to 70, or 35 to 85, or whatever. So pick some range of 50 numbers. And I want to see how many of you will capture my actual number that I've written down on my piece of paper. So if you can throw it in the chat box real quick, throw it in the chat box, some range of 50 numbers. This is technically, some of these are 51, but whatever, good enough. This isn't rocket science. We're generally there. So around 50 numbers, pick a range, maybe you might go, I'm going to go 50 to 100, or I'm going to go 40 to 90, or I'm going to go, whatever, 45 to 95, or whatever you want. Pick a range of 50 numbers, and a lot of you will capture my number. I've written down a number between 1 and 100 on my paper. So put into the chat box whatever you want, as long as it's a range of 50 or 51 numbers. And I want to see how many of you can actually get it right. That's part of the deal. So I've got a few responses. I'm looking for everybody to throw something in the chat box. I've got a chunk of you. I want to see how many can get it. I'm going to keep track of how many actually get it. All right, how are we doing? I'm going to give 30 seconds more. 30 seconds, throw a number in the chat box. I mean a range, sorry, not a number. I've got a number. You throw a range. If you haven't, throw a range in the chat box. 50 numbers, 51 numbers, whatever, around that zone. See if you can capture my number. 15 seconds. I want to see how many people get it. What do you guys think? What portion of the class do you think will get it right? All right, we're out of time. So no more putting in the chat box. Here's my number. My number was 79. That was my number. Let's see how many got it. Rosalinda got it. Lisbeth got it. No, no, not quite. Didn't quite get it. So I've got one that's got it so far. Brenda didn't quite get it. One. Oh, people are coming up just a little short. Oh my goodness, only one's got it so far. Okay, Coda got it. Santiago, Jonathan got it. That's 3. Viviana got it. That's 4. Vicente got it. That's 5. Ooh, Vicente very barely got it. It's 5. Stephanie got it. That's 6. Kenna got it. That's 7. Natalia got it. That's 8. Natalia always gets it. It seems like. Dasney got it. That's 9. And okay, so it looks like 9 people got it. I don't know how many. It looked like, I don't know, it might have been around 8. So it looks like it's about half the class, doesn't it? So it looks like 9 captured my number. 9 of you captured my number in your group of 50 numbers, you know, your interval of 50 numbers. 9 of you captured my number. 9 got it right, which was probably about half of you that actually put in a number. There's 23 of you total. I think around 19 or 20 put a range of 50 numbers in there. And so that's about 50% got it. About 50% got it. Okay, so that's what a confidence interval is, right? Now, what if I let you, here, I'm going to pick one more number. Let me pick one more number. Let me see here. I'm going to do, okay, I'm going to pick one more number. Okay, I just picked another. Let's do this one more time real quick. I just picked another number between 1 and 100. This time, what I want you to do, let me do one more time, and I want to show you the difference and really get the idea of a confidence interval. Now, I have picked another number. I have picked a number 1 to 100. Again, I've written it down on a piece of paper, my paper here. What I want you to do is pick, let's say, 70 numbers. You can pick them however you want. You can say, I want to do like 10 to 40, and that'd be the first 40, and 70 to 100, right? That'd be like 40 and 30. That'd be 70 numbers. Or you could just pick, 10 through 80, or 1 through 70, or what's that, 30 to 100, or you can pick it in 2 different chunks. You can pick it however you want. Pick some interval of 70 numbers and see if you can capture my number. This will be the last time. Let's throw it in the chat box real quick. Pick some interval of 70 numbers however you want. It could be 70 straight, 70 in 2 or 3 groups, whatever you want to do. Pick about 70, 71, I don't care, 70, 71 numbers, something around that neighborhood. See if you can capture my number. I've written down a different number between 1 and 100. So throw in the chat box a group of 70 numbers. So you're getting more numbers this time. Last time we did an interval of 50 numbers. This time we're doing 70 numbers. Okay, I'll give like 15 seconds more. Then I'm going to tally it up and we'll talk about it. Throw in the chat box a group of 70 numbers, however you want to do it. 70 or 71, whatever. We good? Everybody in who wanted in? I'm going to go check it. Check the chat box. Okay, I'm going to tell my number now. My number was 51. That was my number. I wrote it on my paper here. Let's take a look. How many people got it? Now I'm trying to see. I'm going to work my way back up. Looks like Kenna got it. Viviana got it. Teresa got it. Kevin got it. Jennifer got it. Everybody's getting it. Juan got it. And Vicente got it. Stephanie got it. Oh, no. Oh, yeah. Stephanie got it. Yeah, Stephanie got it. Santiago got it. Rosalinda got it. Elizabeth got it. Brenda got it. Yeah, so I think that's where we started. I think it was starting at Brenda there. It looks like every one of you actually got it. 100% of you got it. So every one of you captured my number, my 51, right? Every one of you came up with an interval that captured my value. Now, why were you more likely to get it this time than last time? It's a silly question, obviously, because I let you do 70 numbers, right? And last time you did 50 numbers. So the point is, the wider your interval, the more likely, the higher percentage chance that you're going to capture the actual number. Well, that's what a confidence interval is all about. That's what we're doing today again with confidence intervals, is we're picking a number that we're forming an interval that we hope contains the real deal. That's what a confidence interval is all about, is doing something like that. So that's what it's about. So in real life, for example, they're polling right now for the national election. They're trying to figure out how much vote everybody's going to get. So what they'll do is they'll form an interval. They'll say, I think that this certain candidate is going to get somewhere between 40 and 48% of the national vote, right? So they're giving a range, an interval. What they're trying to do is they're hoping to capture the real deal, right? When November comes out and the real election is all counted up, sounds like it might be tricky this year to count everything, counted up, they're going to find maybe the real answer comes out to be 47%. In the end, the candidate actually received 47% of the national vote. So then the pollsters got it right, meaning their interval did contain the actual true value. But if the actual true value ended up 49%, then they missed it, barely, right? Their interval did not quite contain the true actual final value. So that would be a failed confidence interval. Does that make sense? So they try to form a confidence interval, and they're hoping to capture what really happens eventually. And then they'll give you a level of sureness. They'll say, okay, we are 95% confident, because you're never 100% sure, right? Crazy stuff can happen. So they'll say they're 95% confident that the candidate will really receive somewhere between 40 and 48% on election day. And maybe the candidate ends up receiving actually 47% or whatever. So they'll give you how sure they are, the probability that they're going to get it right, that the real value will end up in their interval. That's what a confidence interval is. Just like you guys were more sure that you would capture my real number. You did. Every one of you did, actually. Captured my 51 on part 2 when I let you pick 70 numbers, right? It made you more sure, higher you'd be willing to bet money that you would get my number because you had a higher percentage chance. We can't be gambling online with our math teacher. I'm sure that's all kind of illegal practice. But anyway, I'm just referring to the idea, right? You would be willing to bet money because you had a lot of confidence. So, and then back when you picked only 50 numbers, you weren't as sure. You had a lower level of confidence that you would capture my actual number. So that's what a confidence interval really is.